Hello students, myself Akshay and you are watching Educare TV. So students, today I am going to discuss about the free body diagram, and as we did in the last lecture, that the free body diagram of an example that I have taken. So I will continue from that. And so one thing we have left in the last lecture, that is the free body diagram of this cane basically. So for that, this cane, all forces we have done, one more forces that will be from the normal reaction, we can say from the surface or ground. So I am taking one more example for going further to free body diagram. First of all, we need to understand about the typical supports. Say this is a hinge that is we can say hinge or roller. Three types we will study about the three supports. One by one we will study. First one is roller support. What this roller support is, basically we denote it like this. This is our roller support. What it does basically, if say that is in this direction, it can move with this roller. Also it can allow this beam to rotate about this point, this axis. It can rotate simply something like this. This can move through rollers, and it can also rotate about this point. Means this is the symbol of this roller support, that what are two movements can be possible. First one is the straight movement in x direction, and the second one, that is the rotation, we can say about this point. And it doesn't allow to move in y direction. It will not move up and down. It will resist the movement in y direction only, but it allow the movement in direction, that is the x direction. Okay, so this is about the roller support. Okay, second one is hinge support. This was the first one. Second one is hinge support. What this support is, basically what we saw in this roller support. In roller support, it allows the movement in x direction and doesn't allow the movement in y direction. Not y direction, we can say we have taken this x direction, it may be we may take as y axis. Okay, so there is no specific term that we say x direction and y direction. It may, but it allow only in one direction. That's the important point to be noted here. It allow, this roller support allows the movement only in one direction, and that will be about the rollers, that will say basically in this direction. So what, and also allow the rotation about this point. Okay, what hinge support, we denote it like this. There is no roller. Okay, say one beam is there. So what the hinge support, basically it doesn't allow the movement in either in x direction or y direction. Both the direction it resists the movement. Okay, and only allow the rotation about this point. Say we have this say beam, and this is connected to the any hinge support. Say this is our hinge support. So it cannot move in x direction. Also it cannot move in y direction, only it can rotate about this point. Okay, so this is the hinge support basically. So that is the difference between roller support and hinge support. So what we do actually, say I am standing in this ground, so what the I can move in horizontal because there is no resistance. I can say any direction I am moving, there is no resistance, means no one is opposing me, but I cannot move in vertical direction. Okay, I'm not able to move in downward direction because someone is opposing me. That's the ground that resisting me in movement, that is in the y direction. So there must be a reaction force through which it is opposing me to move in that direction. So likewise here also, in this case, there this roller oppose or cannot allow the movement in y direction. So it will, we can draw this free body diagram for this beam at hinge roller support. This roller support, only one force will be active. Okay, so this is basically the roller support, and that in hinge support there will be two forces. Okay, because there are two resistance in two direction, that is the x as well as the y direction. So for that we can draw free body diagram for this. Say this is our beam, it cannot allow, it is not allowing the movement in x direction, so it will apply some force in x direction. Okay, that was the force in y direction, say, and also it is not allowing the movement of beam in y direction, so it will also apply some force, that is the reaction Fy. Third one is fixed support. We represent fixed support like this. This is our fixed support, means it doesn't allow any type of movement, that we say actually it will not allow the movement in x direction, y direction, as well as the rotation, that will that we saw actually in case of roller and hinge it was allowed, but in case of fixed support there is no kind of movement is allowed. Okay, so we will simply represent this, that is the free body diagram. It will apply some force in y direction, it will apply some force in x direction, as well as it will apply some moment, that we say actually, because rotation is all about the moment. If moment is there, then it will rotate, so it is opposing the rotation also, so it will apply some moments to this point. Okay, so say moment z is applying here. Why the z? Because we say this is x, this is y, and this is z. So basically if this fixed support applying some moment, so the direction will be in the z direction, obvious. So that's why we have taken m, that is moment about the z axis. Okay, so this is we basically use all this representation of free body diagram in complex mechanical system. So one mechanical system we will do, and that will clear all these concepts basically. So I am just drawing one thing you have to remember, that in roller support, what it was, it allows the rotation. That's why it allows the rotation as well as the movement in x direction. It will only apply the force in the y direction because it is opposing in only that direction. So there will be no moment by this support because it is allowing the rotation. So likewise for hinge support, it will apply the force in x direction as well as the y direction because it is opposing the movement in x direction as well as the y direction, but it allows the rotation of this beam. So it will not apply any type of moment because it is allowing the rotation. Third one is fixed support. It doesn't allow any kind of movement as well as the rotation. So it will apply the force in x direction as well as y direction and the moment, okay, about the z direction, because it will oppose the rotation also. If we try to rotate this, it will not allow. So you are applying some moment. So to cancel that moment, this fixed support also applies the moment in opposite direction of that applied moment. Okay, so that was the three supports we just studied. So I'm doing one example that will clear you. Roller support. These are joints basically, and one block is there, say of mass m. Okay, so here we say A, this is point C, D, B, not B, this is E, and this is point B. Okay, and this is F. Now we want to draw the free body diagram of this complex mechanical system. So what we do actually, we will just apply what we studied till now. First, FBD. Okay, first I am drawing for AD. Say this is A, this is B. This is hinge support, so it will only allow the rotation and oppose the x direction and oppose the movement in x direction as well as the y direction. So it will apply some force in x as well as the force in y direction, and there will not be any type of moment because it allowing the rotation. For this is basically D, no? This is D. So there is a kind of a force in the right direction. So it will some force in the right direction, say dx. Okay, because at point D it is acting, that's why dx. And also it experience some force in this direction. So I just try to say that either in x direction I resolve that and I say f dx, and also in y direction this is say f dy. Okay, at this point. So we can continue D to B, because it is basically a same beam, we can say. This is point B, and point B also it will experience some force in X direction as well as FBX and FBY. Okay, so this is this is point F and this is D. Sorry, this is point B and this is D. That's why. Okay, now I think you have a question, why I have taken the direction of force, that is Bx, in right direction. Why I am taking? I don't have any type of answer, because you may take this into the left side. I don't know the direction, in which direction it is acting. I feel in the right direction. You may take this force in the left direction, but one thing you have to remember, the consistency for you have taken the force. I have taken the force in a right direction for this AB. Then when we draw the free body diagram for this BC, then we will have to take the force in the left direction, because I have already taken the force in the right direction. That is the equal and opposite, as per the Newton's law, we know. So that was the case, and in this point also you can you can do the same thing. That was the for AB. Okay, now I am drawing for BC. This is C, and also it will experience some force in the downward direction due to its weight, and that will be at the center of gravity. Say this is the center of gravity, and it will experience some force in the downward direction, that will be weight of AB. Okay, this you have to mind it. Now I am drawing for BC. This is say C. Okay, and this is basically roller, and as I said, it will only oppose the movement in y direction, so it will give some force only in y direction. It will be Cy. Okay, and it is basically at the point A, so I can write FAY, and this is AX. Okay, now WB, W, that is WBC, due to its weight, and at point E, say this is our point E, and as we can continue from that we can apply either in this direction or this direction. That will depend upon the free body diagram of D. Okay, so first we can draw the diagram of D, then it will be clear. Basically this is say D point, and it will experience some force in either left or right direction. That will depends upon the point D that I have taken here. So here in this beam it is right side, so for this, okay, it will be in the left direction and of the same magnitude dx. Okay, and it is up here downward direction, so it will experience in the upward direction. Okay, so F dy, this is point basically D. Okay, for this point, that is E, we will say in this direction it is applying. You may take in left direction. If you are taking here left direction, then you have to remember that, and you have to put in the right direction here, because equal and opposite, because this is the same point E. Okay, here also, so it will say F EX. So this is point E and the force is F E Y. So now we can draw here, this is point basically E, so equal and opposite reactions, here it is in the right direction, okay. So here it will be in this direction and of same magnitude Fex, and it is here upward direction, so for this we will draw the downward direction Fey, okay. Now what about the point B? Say we have taken here Fbx, so it will experience some force in the left direction that will be equal to Fbx. It may or may not be equal because there is no such kind of normal reaction, because there are three joint, okay. So some force will be balanced by this and some force that will be balanced by this B part, so we cannot say that this magnitude will be equal to for this, okay. So that's why we have taken here Bx dash. Similarly for in the downward direction, say F By dash, okay. Now if we try to draw the free body diagram for this Bf part, this is say Bf and this is say F, and here we have to draw for its own weight, that is say WDE, okay, and here we have shown, okay. Now for this it will experience some force in the downward direction due to its own weight, say WBF, also due to this mass M, say plus WM, okay. Two forces are acting due to its own weight as well as the weight of this block, we can say. And at B it will experience some force in the upward direction, say Fby, okay, and that will equal and opposite, okay. So we can directly we can write as in the upward direction it will be WBF plus WM, that two forces, we can say this resultant forces, that is WBF plus WM. And for joint this B, if we try to draw the free body diagram, what will happen here? Say this is our point B, then there will be some force due to this force Bx dash for this B part, so it will experience some force in the right direction that will be equal and opposite due to this, so F Bx bar, and in this direction it will experience some force because of the A B part it was in the say right direction, that is F Bx, so it will experience some force in the left direction that will be equal and opposite, so F Bx. And similarly for y direction also, here for BC part it is in downward, so for this it will be in upward direction, F By dash. And similarly for this AB part it is experiencing the force in downward direction, that is F By. The same force will be experienced by this point in the upward direction, okay. So we can say F By. So this is basically the free body diagram of this complex mechanical system. So now you will appreciate about this benefits of this free body diagram, because if we try to solve without doing all this to this mechanical system, it will very difficult to solve without using this free body diagram. Now after drawing the free body diagram, you can analyze any part of this system. If you try to analyze the BE part, how it behave, what are the normal reaction, you can study about through this B part. You can simply, you can anything, you can find what the normal reaction after applying the equilibrium conditions, what the we say basically we studied.